Hi everybody. Today we are going to be working with finding a few things out about a capacitor circuit. The capacitor circuit we're going to work with first of all is a parallel circuit. I can tell that it's parallel because of this branch right here. We said before that if we're working with a series, we can move our pen through the circuit, completely through the circuit, without lifting our pen up or going back over itself. That's if it's in a series. We see that we can't do that here. I would go back over myself, or I'd have to lift up my pen and start again. That's what makes this a parallel circuit. So I first want to find what my equivalent capacitance is going to be. Now, in parallel, this is pretty easy. My equivalent capacitance is just the sum of my two capacitors. So, in this case, that's going to be 25 microfarads plus 34 microfarads, which gives me an equivalent capacitance of 59 microfarads, or 59 times 10 to the negative 6 farads. So I'm going to fill that in on my little table that I've written, like so. Next thing that I want to know is, what is the total charge? Now, if you remember, in series, the total charge was the same on each capacitor. So that was one easy step to do. Here, the total charge is going to be changing from one capacitor to another. So it's important to know what our total is going to be. We know that capacitance is equal to Q, our charge, divided by our voltage. That makes our charge, our capacitance, times our voltage. So my total capacitance, 59 times 10 to the negative 6, times my voltage, which is my battery. That gives me, if I plug into my calculator, a total charge of 0.00142 coulombs. That's going to be the charge that is stored by the entire circuit. I now want to break that down and figure out how much is on each of my two individual capacitors. To do that, I am going to need to know the voltage. And the good thing about that is, in parallel, voltage is constant. So V1 and V2 are both equal to the voltage of my battery. So since I know their two voltages, I can easily find what my charge is by doing the same formula that I just did. The only difference is I'm going to use the individual capacitances. So for my first one, that's going to be 25 times 10 to the negative 6 times 24 volts which is 6 times 10 to the negative 4th coulombs. And then I'll do the same thing for my second capacitor, which was 34, times its voltage, which again is the battery. And that gives me 8.16 times 10 to the negative 4th coulombs. Okay. Now, before I go any further, I want to check that I'm right. And the great thing about circuit problems is they have a fail-safe. When we did our series, we could add up the voltage and it would be equivalent to the battery. Here, I can add up my two charges and it should be the same as my total charge. So let's see. 6 times 10 to the 4th plus 8, negative 4th, plus 8.16 to the negative 4th. If I add those two together, I actually get 0.001416, which is the same as what I had written down for my charge. Okay. Now I have one last thing to do, and that is to find my energy. To find the energy, I'm going to use my energy formula, which is QV over 2. So I'll do that for capacitor 1. So 6 times 10 to the negative 4th times 24 divided by 2. And then for my second one, it's going to be 8.16 times 10 to the negative 4th, also times 24 divided by 2. And I'll just plug these in. And we get 0.0072 joules. And .0098 joules. So what we see is that the two capacitors have the same voltage, but my lower capacitor is going to have less charge than my higher capacitor will. Okay? All right, so this is how we solve a parallel circuit of capacitors. My next video, we will look at combinations of series and parallel. Thank you.